Hi, welcome to this quick how to help video on generating sequences from a given rule. Now, I'm not just going to stick with linear sequences. We will, the very last one that we do will be an example of just how it works and they get a little bit more complicated. And actually what you'll see is nothing's different. The maths has got a little bit harder because the rules got a little bit harder, but our approach and our method, it won't change at all, okay? So first thing I want to mention is some of the language that you might hear or read with a question like this. So it could start off by saying, write the first 4 terms. So the first 4 terms. And sometimes that can be a little bit off-putting. It really does just mean the first 4 numbers of the sequence, okay? Each number in the sequence is referred to as a term. So that's why they're going to use it within an assessment or an exam situation. So first 4 terms, and then they'll give you a rule. So the first 4 terms for the rule, let's say 3n plus 2. Now, does take a little bit of work. There's no quick shortcuts, but we can start looking at it, seeing what happens if we're clever. Okay, so first of all, our rule is 3n times 2. That means 3 times n plus 2. And I quite like seeing what it means because it means I can then see what I need to do. If I want the first number of the sequence, then the number 1 is going to replace the n. So I'm going to be doing 3 times 1 for the first number in the sequence. And then I'll do that piece of maths. 3 times 1 is 3 plus 2 is 5. And I've got my first number. If I want the second number, then my n is going to change to 2 to represent, I want the second number, please. And then I do that piece of maths. So 3 times 2 is 6, plus 2 is 8. I now have the second number. If they want the first 4, then I'm going to have to do this 4 times. So I've now put in a 3 where the n is to find the third number in the sequence. 3 times 3 is 9, plus the 2 is 11. And then the last is 3 times 4, which is 14. So we've got 5, 8, 11, and 14. And that's it. And it's that same technique and that same process regardless. You may spot that these are adding 3 each time. And if you did spot a pattern like that, it might save you just a little bit of time here. But the caveat with that is it doesn't always happen. If I give us a more complicated rule, maybe one with a power 2 in it, which is what I'm going to do at the end of this video, then you're not going to see this kind of pattern necessarily. There are other hidden patterns, but not this sort of linear going up in the same amount each time. Okay, I'm going to do another one like this so that you get a chance to just see what that looks like again. And then I will replace a much harder rule just so that we can see how that does work. So we'll do this time 5n minus 4. So I'm going to show that the rule means this, and then the first one's going in. First term, 5 times 1 take 4, which is 1. And the second number means I'm putting a 2 in, and that's going to give me 6. The third one is 5 times 3, take 4, which is going to give me 11. And the last one, 5 times 4, take that 4, is going to be 16. And hopefully you are noticing how everything is really consistent. 5 is at the beginning of my rule. It's at the beginning of every part of calculation. The n is the thing that changes. Minus 4 is staying in its place. If you're being asked to generate something a little bit trickier, we are not going to change the process. we don't want 100 different ways of doing things. We want one way that works all over the place. So let's say I've got 2n squared. Let's do plus n. Let's really go for it. The n is in there in 2 different places, but I'm not going to change a thing. I'm going to write out what it means. 2 is squashed to the n, so that means times n squared plus n. If I want the first term, everywhere there's an n, I'm now going to write a 1. So I've got 2 times 1 squared plus 1. I must make sure I think about my bidmus so that I do everything in the right order. So this is where it is harder because I do have to consider things like that. So I'm going to do 1 times 1 is 1. Times that by 2. So 2 times 1 is 2 plus 1 is 3. I did this middle section first because it's an indice, and that's the I in bidmus. Then I did it here because of the multiplication, and I did my add 1 at the very end. So let's see it again. This time, the n is changing to 2. And I must remember to change it here as well because I've got the n in 2 places. Okay. I'm going to show in red so that you can see the numbers coming out. So 2 squared is 4. So I've done the I bit. The next bit I need to do is this bit, 2 times 4, which is 8. Add on the 2, and I get a final answer of 10. Now the third number is going in. So I've got 2 times 3 squared plus 3. Again, I'm going to write it down so that I don't lose what I'm doing. If I try and hold it all in my head, I'm making my head work harder than I need to. 3 squared is 9. I've got that times 2 and plus 3. 2 times 9 is 18. So my final answer when I add on that 3 is 21. And last but not least, in goes the fourth number. So we've got 2 times 4 squared plus 4. My 4 squared, 4 times 4 is 16. 16 times 2 is 32. So this bit here is 32. Add on my 4, and my answer is 36. So my sequence is 3, 10, 21, 36. Okay, generating sequences. This technique is the exact same technique for getting the coordinates for drawing a graph. So if you were to watch that video on generating coordinates to draw a linear graph or a quadratic graph, you would see this exact same math. This key skill is the same skill in both topic areas. Okay, hopefully you have found this video tutorial useful and it is helping you make sense of generating sequences. Thank you for taking the time to try and learn with us today.